Paradoxes of voting. This is an extremely important topic, and for me, this is the most interesting lecture. We'll be discussing different paradoxes associated with different voting methods. We are not going to go over the comprehensive review of such paradoxes. We'll just discuss a few paradoxes per method, the most interesting from our point of view paradoxes. But the number of possible paradoxes is huge. For now, we have learned about one such paradox, one problem with majority method when we have three or more voters, the Condorcet or voting paradox. So as you remember, this is our voting profile with a cycle. We had that X is preferred to Y because XY, YX, XY, X beats Y 2 to 1, and Y is preferred to Z. But also Z is preferred to X if we calculate the numbers of votes in favor of Z against X. And this creates many secondary problems here. But there are problems that are of different sort. They are not directly related to the voting paradox, but they are sometimes incredibly weird and disturbing. So we'll start discussing the paradoxes of managing orderings and agendas. What sort of inefficiencies we can see here. So again, we have the voting paradox profile with a cycle. And now the problem that is directly evident from the identification of this paradox is that we have a strong sensitivity of outcomes to the managing ordering. As you recall, if we assume the managing ordering X, Y, Z, then X beats Y and the Z beats X. If we assume, say, Y, X, Z, well, this will be the same, so the same outcome. So no, let's use something else. Y, Z, X, then Y beats Z, and X beats Y. And finally, we have our third option, essential third option, when Y is the last alternative here, and it is X, Z, Z beats X, and Y beats Z. So all alternatives may be winners. It only depends on what sort of agenda we are going to apply. And this also creates inducement for strategic voting. For any managing ordering, for any of those agendas, there is a voter with incentives to misrepresent his or her preferences. Let's take a look at the first agenda, X, Y, Z. Under this agenda, Z is the winner. Z is the winner. And now let's take a look at the incentives of our voters to misrepresent their preferences, to vote strategically. Z is the last choice of voter number one. So now voter number one actually could think about, does it make sense for me to vote for X in the first round? Or maybe I should vote for Y. So this is what voter one can do. Exchange the preferred alternative X with the second alternative of Y. And then we'll have the following outcome. X, Y, but now we have two votes for Y, Y and Y. Y is the winner. And in the second round, Y beats Z. So assuming that voter number one votes strategically and other voters vote sincerely. So this is the incentive for strategic voting for lying. We'll see that actually this is universal. that there is no voting rule, sensible voting rule, that would be immune to this kind of problem. But we'll do this later. Now, there is a possibility that managing ordering fails to choose a unique weak Condorcet winner. So now we have a voting profile with 4 voters and 3 alternatives, and the managing ordering is XYZ. So let's take a look at who is this weak Condorcet winner. We have XY, YX, XY, YX. Here there is tie, and now XZ, ZX, ZX, ZX. So Z beats X, and now Z against Y. ZY, YZ, YZ, ZY, YZ. So Y ties with X. Y to X is 2 to 2, and Y against Z, it was 3 to 1, while X against Z was 1 to 3. So Z is not a weak Condorcet winner because it loses to Y. X loses to Z, and Y actually beats Z and also ties with X. So Y is a weak Condorcet winner. But what happens if we apply this managing ordering here? X, Y, Z. X, Y, Z. X against Y. It was 2 to 2, but our tie-breaking rule was telling us that X must be the winner. So X goes to the second round. And now X against Z, Z is the winner. So we had a weak Condorcet winner, but actually this Condorcet winner didn't win. Now what if we have a strong Condorcet winner under sincere voting? Is it possible for a strong Condorcet winner to lose? And the answer is very simple. Strong Condorcet winner must always win. Win with sincere voting. Why? Well, at some point with any agenda, our Condorcet winner must enter the elections. And because of the definition of the strong Condorcet winner, the first time it enters the elections, it must win. And then it keeps winning. We assume sincere voting. So voters vote according to their preferences. And according to those preferences, our Condorcet winner wins with any alternative. So it must win. There's no way for a paradox similar to the paradox that happened with the weak Condorcet winner. But now we have more serious problems. We may have an alternative that is unanimously preferred to the winning alternative. And well, this alternative may lose. So this is our problem. Just 3 voters, 4 alternatives, and now which alternative is the winner according to this managing ordering? So let's do this. It's Y versus X, then Z and V. So Y against X, who is the winner? YX, YX, XY. So Y is the winner 2 to 1. Y against Z, YZ, ZY, ZY. Z is the winner. And now Z against V, VZ, ZV, VZ. V is the winner. And if we compare X and V, we see that X actually is preferred by everybody to Z. So V is the winner, but all voters prefer X to V. But actually the problem is much more serious and much more fundamental. We can take a look at another example with a long agenda. We have now 7 candidates in the elections, 7 dwarfs. Not a nice way of talking about politicians, but I am not unsympathetic. 7 dwarfs, just 3 voters, and these are their preferences. Those cute names: Happy, Sneezy, Grumpy, Dopey, Dog, Bashful, Sleepy. So we have those preferences. They vote sincerely. And here is our agenda. So our first round of voting, it is Dopey versus Happy. Happy, Dopey, Dopey, Happy, Dopey, Happy. So Dopey is the winner. Now Grumpy versus Dopey. Grumpy, Grumpy. Grumpy is the winner. Sneezy versus Grumpy. Sneezy, Grumpy, Grumpy, Sneezy, Sneezy, Grumpy. Sneezy is the winner. Sleepy versus Sneezy. Sleepy, Sneezy, Sleepy, Sneezy, 2-1. Sleepy is the winner. Bashful versus Sleepy. Bashful, Sleepy, Bashful, Sleepy. Bashful is the winner. And Dog. Dog, Bashful, Bashful, Dog. Dog, Bashful. Dog is our overall winner. So we have a winner in the elections under this agenda. Dog wins. But now, if we take a look at where Dog is in everybody's preferences, Dog is very low in everybody's preferences, actually. Everybody prefers first Grumpy. Grumpy is preferred by everybody to Dog. Well, Happy is preferred by everybody as well. Sneezy, 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 yes. Sneezy is also preferred by everybody. Sneezy and Sneezy. And what about Sleepy? No, Sleepy is not preferred. Bashful is also not preferred. So we have, did I mention Dopey? Dopey is also preferred. Dopey. So now we have Happy, everybody prefers Happy, Sneezy, Grumpy, and Dopey over Dog. So Dog is a candidate who is very, very low in everybody's preferences. 4 out of 7 candidates are preferred by everybody to Dog. Nevertheless, under this particular agenda, Dog wins. This shows you the potential of manipulation that is hidden in this concept of agenda. There is a theorem by Richard McKelvey that shows that the problem is more universal. We don't have time for discussing this. This is a pretty not non-elementary result, but in spatial models of voting, this is one of the most fundamental theorems that generated a lot of discussion, a lot of work was out of this. And Richard McKelvey was a clear candidate for a Nobel Prize. You know that political scientists get Nobel Prizes from time to time in economics. But he died, unfortunately, very young and didn't get it.